I pushed it off long enough. We're going to have to do this one. Everyone who has asked a question about the homework pretty much has asked about this particular one. So we are looking at homework number 4, question number 9. This is the infamous falling screwdriver question. We have a construction worker who is at the top of a high-rise building, and he drops his screwdriver, his electric screwdriver. I can't draw, so that's a corn dog. He drops his electric screwdriver from a height of 400 feet. So he's up here at 400 feet. The ground is right down here at 0 feet. So the corn dog's basically going to travel from 400 feet to 0 feet. Did I just say corn dog? It's a screwdriver. What else do they tell us? They tell us that after t seconds, the screwdriver has fallen a distance of s equals 16t squared feet. Okay, that's some letters and some numbers, but what does it mean? So s equals 16t squared feet. S is the distance of the fall. So we'll say the distance of fall. That's how far our screwdriver has fallen. And t is time in seconds. So that's some useful information, and it's going to come in handy right away, because the first question they're asking us is how long did it take the screwdriver to reach the ground? So how long did it take for the screwdriver to reach the ground? Okay, valid question. So, what's the distance between the top of the building and the ground? Well, ground is 0, we said. Top of the building is 400 feet. So that looks like a distance of 400 feet. And in our formula up here, we have the distance of the fall as this s. So I'm going to plug in 400 for that. 16 t squared, time in seconds. Well, that's what they're asking us for. They want to know how long it took. So I think if I set it up like this, I can actually solve for t, and I'm going to get the answer that I'm looking for, because t tells me how many seconds it took to fall 400 feet. And because I want to get my t on the other side, I'm actually going to rewrite it. 16t squared equals 400. T squared, then I'm going to divide by 16 on both sides, equals 400 divided by 16. And that actually happens to be 25. So I've got t squared over here, 25 over here. If I take the square root of both sides, I'm going to end up with t equals 5. And that t is time in seconds, so it's 5 seconds. So for the first blank, where they say how long did it take the screwdriver to fall or to reach the ground, the answer is 5. And so you will plug in a 5 or whatever, because your number might not be 5. Your height might be different. But if you follow these steps, set the height equal to the function that they gave you and solve for t, you're going to get your answer for part A. Okay, so now we need part B. Part B is, well, it's just another question, and we just have to figure out what they're asking so that we can give them the answer that they're looking for. So the question for part B, make sure you can see that in the screen here. What was the average, I can spell, velocity of the screwdriver between the time it was dropped, abbreviate for between time dropped and time landed, basically. So they want to know what the average velocity of the corn dog was between the time it was dropped and the time it hit the ground. And velocity is something we measure in feet per second. I'm not quite sure how the people who wrote this question wanted you to know what you had to do here, but what we need for finding the average velocity is something that we talked about back in, I think it was problem 4, where we were doing some average rates of change. What we want is the velocity between time 1 and time 2. So time 1 is going to be the time that we dropped this. If you were holding a stopwatch and you started the stopwatch at the moment you dropped the screwdriver, time 1 would be 0. The time it landed, well, we figured that out back in step A. That was 5 seconds. So T2 is going to be equal to 5. And the way that we set up these average problems is we took, in this case, our functions are s. So we take s of T2 minus s of T1 and put that all over T2 minus T1. So that's looking at the function at the end minus the function at the beginning, and it's dividing it by the difference in time that it took to fall. So what was our function? I should probably write that back down again. Our function was 16, so s of t equals 16 t squared. So we need s of t2, so that's going to be 16 times 5 squared. I just plugged in a 5 for where the t was because we said our t2 was equal to 5. And then minus s of t1, which was 16 times 0 squared. I'm liking that. And then t2 minus t1, so that's going to be 5 minus 0. And I think we could do a little simplification here. We've got 16, let me move this up a bit, 16 times 5 squared. This goes away, over 5. I can actually take that 5 and cancel out the exponent, and I wind up with 16 times 5, which just so happens to be equal to 80. And 80 feet per second is the average velocity that our falling screwdriver had between the time it was dropped and the time it landed. So your answer in part B you're going to get to by doing this s of t2 minus s of t1 dividing by t2 minus t1. And if you have to, rewind the video, go over this part again until it makes sense. It's a little tricky. Or go back and look at number 4. The question number 4 is very similar to this, and we kind of walked through that a few times. So that's how we get part B. And finally, we need part C. So what does part C ask us? They are asking on part C, what was the velocity of the screwdriver at the time it hit the ground? So what was velocity at time that the screwdriver hit the ground? Good question. I think every time I've seen a problem like this, I always think, well, when it hits the ground, its velocity must be 0 because it stops dead in its tracks. But that's not the case. The split second that it hits the ground, it's still moving until it's actually on the ground. So we do actually need to figure this out. So they're asking for the velocity at a specific time. And the words that should pop into your mind when you hear that is instantaneous. Instantaneous. It's happening at a specific instant. So we need the instantaneous rate of change. And to find the instantaneous rate of change, we're going to have to find the derivative of our function. So we had s equals 16t squared as our function. We're going to have to find the derivative of that. Since this is homework 4, I trust you are all going to dutifully do the 4-step process. That's what should happen here. The 4-step process to find this derivative. And once you have done that 4-step process, you are going to find out that s prime equals 32t. Okay? So that's useful. Now what do we plug in for that t? Well, they're asking what the velocity was at the time the corn dog hit the ground. What time did the corn dog hit the ground? Go back to A. We said it took 5 seconds for it to hit the ground. So we want S prime of 5, which is going to be 32 times 5. And the answer there, if you plug it into your calculator or do fantastic mental arithmetic, is going to be 160 feet per second. So that's the velocity of the screwdriver at the time it hit the ground, and it also happens to be the answer to number C. And that's my cell phone vibrating while I'm trying to make a video. Okay, I think that does it for this one. Feel free to go back to any of the parts that don't make sense, and if something doesn't make sense at all or you're still not getting the numbers that you're looking for, I encourage you to shoot me an email or ask me in class, talk to one of the other lab leaders, go to the tutoring center in Middleton 141. Lots of places for you to get help, or just watch the video a couple of times and see if it doesn't clear up after you've kind of followed through on all of the steps. And I am sure I will be back with more videos since that's all I'll be doing tonight.